Hey everyone, I hope you're doing well today. In this video, I'm going to be going over how to solve absolute value equations. While you can find the timestamps here, they're also linked in the description. Simply put, an absolute value equation is an equation that contains an absolute value symbol. Remember that absolute value just means distance from 0. Here's a basic absolute value equation. This 4 represents the distance from 0, and its left side of absolute value of x is asking us which value of x will be 4 away from 0. Here we can see that there are two values that have an absolute value of 4. The absolute value of negative 4 is going to equal 4, and the absolute value of positive 4 is going to equal 4. That being said, we can say that x is equal to 4, or we can say that x is equal to negative 4. There are two values of x that make this equation true. Let's look at an equation that has slightly more pieces here. The absolute value of x minus 3 is equal to 7. Again, this 7 is going to represent the left side's distance from 0. For this left side to be 7 away from 0, this x minus 3 has to either equal negative 7 or positive 7, and that's because negative 7 and positive 7 both are 7 away from 0. From that, we can write two equations of x minus 3 is equal to negative 7, and we can write x minus 3 is equal to positive 7. Solving each of these equations, we find out that x is going to equal either negative 4 or x is going to equal positive 10. While these are just two basic examples, they should give you some insight and understanding of how these absolute value equations are going to work. This represents an absolute value equation with different values for a, b, and c must be greater than or equal to 0 since we don't measure negative values. To solve absolute value equations, you always set the absolute value expression equal to the positive version of c and its opposite. In the rest of this video, I'm going to go through 6 different examples with varying difficulty. The last example will be an application word problem. Let's do some math together. Here in example 1, we have the absolute value of x plus 3 is equal to 8. In order for this x plus 3 to have a distance of 8 from 0, it's either going to have to equal negative 8 or it's going to have to equal positive 8. Since negative 8 and positive 8 both are 8 away from 0, we're going to have to solve two equations. The first equation we're going to write is x plus 3 is equal to negative 8, and a second equation we're going to write is x plus 3 is equal to positive 8. Subtracting 3 from both sides on the equation here on the left, we'll find that x is equal to negative 11. Subtracting 3 from both sides on the equation to the right, we find that x is equal to 5. These are the two solutions that make this absolute value equation true. If you were to substitute this negative 11 in for x here, negative 11 plus 3 is going to be negative 8, and negative 8 is 8 away from 0. And substituting this 5 in for x here, 5 plus 3 is going to be 8, and 8's distance from 0 is also 8. Plotting these solutions on a number line, we can plot a point here at negative 11, and we can plot a point at positive 5. In order to have a distance of 20 from 0, this 3m minus 4 must equal either negative 20 or it has to equal positive 20. From that, we can write 3m minus 4 is equal to negative 20, and we can write 3m minus 4 is equal to positive 20. To solve this equation on the left, we're going to add 4 to the left side and add 4 to the right side. And that'll get us 3m is equal to negative 16. And we'll divide both sides by 3 to find that m is equal to negative 5 and 1/3. For our equation on the right here, we're going to add 4 to both sides. We'll find that 3m is equal to 24. And we can divide both sides by 3 to find that m can equal 8. These are the only two values of m that make this equation true. While these solutions are definitely correct here, keep in mind that you can substitute them back in to check it if you're taking a quiz or a test. If you were to graph these solutions on a number line, you'd put a point here at negative 5 and 1/3, and a point at positive 8. Here in example 3, we have an equation that's a little bit more complicated. This is the first example that has more than just the absolute value expression on the left side. Whenever you see equations like this, you should always move everything to the right side that's not inside the absolute value expression. Let's move this negative 5 and positive 4 to the other side. Let's get this absolute value expression alone. To do that, we're going to start off by adding 5 to both sides of this equation. From that, we're going to get 4 times the absolute value of 2y minus 1 is equal to 28. Then to get rid of the 4, we're going to divide both sides by 4. Since 4 divided by 4 is 1, we can just have the absolute value of 2y minus 1 is equal to 7. At this point, our absolute value expression is finally alone, and we need to find out when 2y minus 1 is equal to either negative 7 or equal to positive 7. Let's write our two equations now. First, we have 2y minus 1 is equal to negative 7, and we have 2y minus 1 is equal to positive 7. Let's start by solving the left equation by adding 1 to both sides. From this, we're going to get that 2y is equal to negative 6. And to get a coefficient of 1, we can divide both sides by 2 here. We'll find that y is equal to negative 3. For this equation on the right, we're going to start off by adding 1 to both sides. And we'll get 2y is equal to positive 8. We find that y is equal to positive 4. These are our two answers. To graph these solutions, we put a dot here over at negative 3 and a dot over here at positive 4. Now let's try example 4. Your first instinct should be to get rid of this negative 8 and this 1/4. We need to get this absolute value of 3p plus 5 alone. First, we're going to add 8 to both sides here. From that, we'll have 1/4 times the absolute value of 3p plus 5 is equal to 7. To get rid of this 1/4, we could either divide both sides by 1/4 or multiply both sides by 4 over 1. Since dividing a fraction is equivalent to multiplying by its reciprocal, this might save you a little bit of time. These 4's are going to cross cancel, and we'll be left with the absolute value of 3p plus 5 is equal to 28. Now that our absolute value is alone, 3p plus 5 has to either equal negative 28 or it has to equal positive 28. Our first equation is going to be 3p plus 5 is equal to negative 28. And our second equation is going to be 3p plus 5 is equal to positive 28. Solving this equation on the left, we'll start out by subtracting 5 from both sides. The 5's will cancel out to make 0, and we'll have 3p is equal to negative 33. To get from 3p to 1p, we're going to divide both sides by 3. From that, we're going to get p is equal to negative 11. For our equation on the right, we're going to subtract 5 from both sides. The positive 5 and negative 5 makes 0, so we have 3p is equal to 23. Dividing both sides by 3 here, we find that p is equal to 7 2/3. These are our two solutions. To graph our two solutions, we'll put a dot here at negative 11 and a dot over here at positive 7 2/3. Here's example 5. Right from the beginning, let's get rid of this negative 9. To get rid of the negative 9, we can divide both sides by it. We'll be left with the absolute value of 4w plus 2 is equal to negative 5. At this point, our absolute value is isolated, but notice how it's equal to a negative value. Since absolute value measures distance, we gotta remember that absolute values can't equal negative numbers. If you're ever solving an absolute value equation and you've isolated the absolute value and it's equal to a negative number, there's no solution. Here in example 6, we have an application word problem. Pause the video to read the question to yourself and unpause it when you're ready to go over it with me. While you may be able to figure out the solutions to this without using absolute values, I'm going to show you how to solve this problem using absolute values. First of all, absolute error is equal to the absolute value of the actual time minus the target time. While this specific problem is dealing with time for a presentation, you can use the same setup for any other absolute value application as well. This would be our verbal model. Since we know that Andrew's allowed to be 15 seconds off, his absolute error is going to be 15. We don't know what his actual time is going to be, so I'm going to use the variable t to represent how long his presentation actually is. After that, we're going to subtract 120 because that's his target time for his presentation. This is our absolute value equation. The two equations we're going to set up are going to be t minus 120 is equal to negative 15, and t minus 120 is equal to positive 15. Hopefully it makes sense that we're going to have two solutions because Andrew can go up to 15 seconds over the target time or 15 seconds below the target time. To solve the equation on the left, we're going to add 120 to both sides. From that, we're going to get t is going to equal 105. For our right equation, we're also going to add 120 to both sides. From that, we're going to find that t is equal to 135. This 105 and 135 represent the shortest and longest Andrew's presentation can be without losing points. While 120 seconds is the target time, Andrew's allowed to be 15 seconds under that time, as well as 15 seconds over that time. And that wraps up this lesson. If you found this video useful, please consider giving it a like or letting me know in the comment section below. Keep up the good work, and I'll see you in the next one.